let's look at problem number 18. So suppose you are to make a rectangular box with a square base. So I'm going to draw myself a box. That is really not good. Got a little crazy there. Okay, so there's my sloppy box. And the base is square. What does that mean?
It's a square.
Those are the same. Okay, and I don't know anything about the height, so I'm just going to call that y for a minute. So there's my box. The material for the top and the four sides costs $1 per square foot. Square foot tells me area. So for the top, what's the area of the top of this box?
X squared.
And how much do we pay for that?
$1 per
Okay.
square foot.
Then we have four sides. What is the area of every one of those sides?
XY.
Okay, and there's 4 of them, so 4 of those. And how much does a side cost? $1. Okay, and then the bottom costs $2. So what's the area of the bottom?
X squared times 2.
And it tells me my total cost is $144. Yeah, sorry, I haven't combined like term sheet. We are trying to find the dimensions for the greatest possible volumes. Volume is length times width times height. So x times y is x squared y. Before, if I ask for a maximum or minimum, we know that means derivative. Before I do the derivative, I need to get it in terms of only one variable. So I'm going to use this equation. X squared plus 4xy plus 2x squared equals 144. Would it be easier to solve for x or y? Okay. So 4xy plus 2 is 144 minus 3x squared. So y 144 minus 3x squared over 4x. Okay, I am going to replace the y in this equation. Would you guys be okay if I just distributed and broke apart my fraction?
Yep.
That way we don't have to do quotient rule when we get ready to do our derivative, although you certainly can. 144 divided by 4 is 36. X squared over x would be x, so we get 36x. Minus 3 over 4, x fourth over x would be x cubed. So there is my volume. Max or min says derivative. Okay, so derivative of v would just be v prime. Derivative of 36x would be 36. Minus here, the 3 comes down, so 9/4 x squared. And what do you set your derivative equal to? Okay, if I multiply by 4/9 on each side, that gives me 16. Square root would mean plus or minus, but can we have a negative here? No, it's representing a side length, so we just get 4. So we had to find the dimensions of the box. So length times width times height. Length and width are both 4 feet. How do I find the y?
Look at that.
Y is 144. And that would be 6. questions there? Three. Tells us we need to find the sum from 1 to n f of x sub I change in x. We know that our function is x squared. The interval is 0 to 2. And then we're going to do the limit to get our exact value. So first we need our change in x. How do we find that?
Just 2 minus 0 over n.
The sum 1 to n. F of x sub I. So our starting point is 0. And then you add your change in x every time. So it's just 2 over ni. So f of that means you replace your x with the 2 over ni times the change in x, which is 2 over n. And you're welcome to go ahead and write your limit on this, or you can save it until added on in the end. It doesn't really matter. Are you guys okay with me here? So if we work this out, 2 squared is 4 times 2 would be 8. N squared times n is n cubed. I squared. So then we use our summation rules. We have 8 over n cubed. What is the I squared formula?
N times n plus 1 times n 2n plus 1 over 6.
I'm going to go ahead and cancel one of those. If you wanted, you could reduce this to a 4/3. If I distribute, I don't want to do too much on this. So think of it as 4 over n squared times 2n squared over 3. 3n over n is just n plus 1/3. So I'm distributing here. So we get 8/3 plus 4 over n plus 4 over 3n squared. And what are we supposed to do with this?
Our limit.
As n approaches infinity.
Because I said find the sum, and then once you have it, do your limit. So that was my sum. Now we do our limit. We know if n is on the bottom, it goes to 0. So 8/3 is our final answer. So we need left, right, and midpoint sums. So my function, x squared plus 2x, on the interval 1 to 4, with 6 rectangles. So first, change in x, 4 minus 1 over 6 is 1/2. If you need to, think about yourself a little bit. Okay, I'm starting at 1. I'm going up by a half. Do you guys want me to work fraction, decimal, if you care? Decimal, so we'll say the next one be at 1.5. Okay. So, area of a rectangle is length times width. These all have a width of 1/2 or 0.5. So we have to add up the 6 numbers within. To get those, we have to look. If you're starting with the left sum, you start with the leftmost point. So I'm going to start with 1. And I'm plugging 1 into my function. So 1 squared plus 2 times 1. And then we just go up by a half. So 1.5 squared plus 2 times 1.5. If you put in, go up by 0.5, that would be 2 squared plus 2 times 2. 2.5 squared plus 2 times 2.5. 3 squared plus 2 times 2. 3.5 squared plus 2 times 3.5. Do you guys understand how I got those numbers? And if you evaluate that, it comes out to be, I think, 30.875.
Yes.
So then your right hand sum. It's the same idea. We start with 0.5, because that's our width. We need our 6 numbers that we add up. And so the difference is you are starting with your rightmost point. So the first number we plug in is 1.5. And then you plug in your 2. 2.5. 3.5. And we have to keep going because we're not there yet. So this one, if you add 0.5, you get to 4. And that was the end of my example. And when you plug that one in, what do we get?
41.375.
Midpoint. Same idea. So we start, our width is 0.5. We need our 6 rectangles. The only difference is our starting point has to be the middle. What is in the middle of 1 and 1.5?
1.25.
If you're not sure, add them up and divide by 2. So 1.25 is the first number I plug in. Okay, and then we go up by 0.5, so the next one will be 1.75. Add 0.5, so 2.25. 2.75. 3.25. 3.75. And that one gives us what? 35.9375. So the difference on these is really just your first point. And then you're plugging those into your equations to get your y's.
Oh, by the way, we don't have to go over 38. I figured it out.
Okay. Did anyone else need to go to the average value?
If we have time at the end.
Okay. So 25, we are just trying to turn this expression into an interval. Alright, so this limit of the sum gets turned into our integral. Where are we starting and stopping? So we're doing an integral from 0 to 3. This piece is my function. The only difference is in the integral we don't do x sub I, we just do x's. So x cubed minus 3x squared plus 1. And at the very end we change an x to just writing it as an integral. You didn't have to evaluate anything. Try and do too much.
I did start when I started 24. I have like half a page of work that's not correct, but I was gonna get there, and then I was like, I'm not gonna get there.
Did you figure out what you did?
Yeah, I didn't do any. I just started just solving,
Oh.
but I couldn't find the left or right or anything because I wasn't doing it right.
Alright, absolute value. So just like if we're doing a derivative, we're going to have to rewrite this. First, you need to know when the inside equals 0. So that's 2. So we are going to integrate from -3 to 2 and from 2 to 3. If you put in something between -3 and 2, so maybe a 0, what happens to the inside? It's negative. So we have to do the opposite of 3x minus 6. Would it bother you if I just went ahead and wrote -3x plus 6?
Nope.
From 2 to 3, if I plug in a number, it's normal. The absolute value does nothing. So that's just 3x minus 6. So now we integrate. Antiderivative of -3x is -3 halves x squared. Antiderivative of 6 is 6x. From -3 to 2. This piece would be 3 halves x squared minus 6x. So if you plug in the 2, 2 squared is 4 times -3 halves is -6. Oops. Plus 12 minus, if you put in a -3, that would be 9, so -7 halves minus 18. Put in 3 here. Minus, put in 2. Or 39. Is that okay? Good.
Even though I just did 32 not 20 minutes ago, it's like left my brain that I even did it.
Hey, random question. Where did the rest of those books go?
They go to the public library.
Is somebody taking them? Thank you.
Angelo's gonna take them.
Okay, I just wanted to, didn't know, I wasn't part of that conversation.
They have sticky notes on them.
Oh, okay.
But there's there's like a couple Christmas books and then a Bible, and we figured we probably should give the Bible to the public school.
Fair enough.
The Bible?
Yeah, because I know it's the truth.
It's the Bible.
But there was actually like a Clefjillion American Girl doll books
Oh.
and Barbie books.
Okay.
So, and we had like a bunch of like bedtime story books that I said we should just give to
Where did you take all
those
those?
to all with the elementary and we figured they could. She's older. Because we figured they could take those home. The little kids could take those home and they could read them at home.
Alright, so what would we have to do on this one? Okay, we have talked about U needs to be the inside. Don't make it too complicated. So, when I'm looking at this fraction, I told you U should always be the denominator. But make it the inside. I wouldn't even include the square root because we don't want to have to do chain rule. I would just look at this part. So if you do the derivative of 5 is 0, so that's gone. Plus 2, what's the derivative of sine?
Cosine.
Angle stays the same, times the derivative of the angle is 3, so 2 times 3 would be a 6.
Yeah.
1/6.
I don't want the 6, so I can divide that over, so 1/6 du would replace the cosine 3x dx. So we're integrating. Cosine 3x dx is my 1/6 du. Okay, I have 1 over the square root of u, or should I just write that as u to the negative 1/2?
Yeah, I guess. Maybe this time.
So, antiderivative, add 1 to the power, so that's a 1/2. Reciprocal in front, so 1/6 times 2 is 1/3. We don't have any limits to plug in, so we need plus c. And then to finish it, we replace the u. So u is 5 plus 2 sine of 3x. Or 1/2. Plus.
I'm gonna forget the C and the U.
My thing is always just I forget to add the, when I do my du, I forget that I have to put dx in the line, cause it like doesn't happen again, like we don't need it
Uh-huh.
anymore.
But you need to recognize it so that you have it when you do your substitution.
Look at this geniusness.
No.
That's the perfect view.
Or high school diploma.
Then it wouldn't be a skibbity U anymore.
This one I thought was gonna be harder than it was.
That's not very simple.
Is it?
I knew the numbers.
I'm
Real
gonna
simple.
read those.
So when I look at this one, I currently have variables being multiplied. Can we do chain rule and, or product rule and reverse?
No.
No, so we have to do a substitution. Now, if I include the sine in my substitution, then the derivative of sine is cosine. Is there a cosine anywhere in this problem? No. So pick a simpler u. What would your u be?
T squared over
1/2
two.
T squared.
1/2 t squared, or the t squared over 2, just that inside part. So du, 2 comes down and cancels, so you get t dt, which, nice enough, is what we want. So that's going to become, did you guys change your limits? I think most of you do, but a couple of you
Oh,
don't.
I
yeah.
don't change my limits.
You don't change your limits?
I love changing my limits.
So if you change your limits, you plug these numbers in for t. 0 squared divided by 2 is 0. Square root of pi squared is pi, divided by 2 is pi over 2. So if you change them, then you leave it in terms of u. If you don't change them, you have to sub back out. So we have sine of u dt. Antiderivative of sine.
Negative cosine of U.
So if you didn't change your limits, this is where you now replace your u. Since I did, we have a negative cosine of pi over 2 minus cosine of 0. Cosine of pi over 2 is 0, cosine of 0 is 1. The opposite of 0 minus 1.
Yay! I remember I did that wrong in my problem. I got 1. Oh, I got 2. It's fine. I don't know what I did wrong, but when I did it here, I did it wrong.
Okay.
I think I put it
I just
wrong.
calculation
Why is
error.
it
Well, because
cosine?
I still had a pi. I had like a whole pi, not a pi over 2. I don't really
Oh.
know.
Yeah.
Cosine is
Just
less
think
one.
of it on the graph.
Cosine
Cosine
is
and cosine and sine.
Mhm.
I'm not gonna lie, when I was sitting in here doing it, I was open mouth.
I mean, just think on the unit circle, cosine is the x, so
Yes.
cosine of 0 is, that's when x is 1.
Yes.
At pi over 2, x is 0. Forehand.
I just
Square root
keep
of bottom over 2.
flipping them.
Mm-hmm.
I just like I
Sine
forget.
is the one on top.
Mm-hmm.
Man.
I don't know why, but you said it, but I think I remember it different than you said it. But I think of cosine comes first.
On
Cause
the,
it cut. And such.
ABC. So wait, AP.
What'll happen if I
Sorry.
end up like,
Sky.
cause I don't even know if I drew my graph right, I'll be so honest, and I'm if I didn't draw my graph right, but I still got the right answer,
So you might miss a
can
point.
that happen even?
It can happen, yeah.
I draw my graph because you want me to draw it, and I
We'll
don't.
see.
I
I
don't
really
look at it
just
from
draw it because I want you to think about what's on top.
Would you take off a point when you drew the graph wrong?
Absolutely.
A point.
I
I mean,
try-
usually the graph is only worth a point anyway, so
This
it's
is
not like you're gonna
well,
miss a
I
bunch.
think
I definitely think it's that.
What is this?
All right.
30 seconds?
So we're only going from 1 to 3. What if we just plug in numbers between 1 and 3? Do you want to do that to get our graph?
So smart.
So 1 cubed is 1 plus 1 squared, so 1 plus 1 is 2. So if I put in 1, we get 2. Right. If you put in 2, we're going to get some big numbers here. I probably don't want to count that big, do I? Let me undo that. Okay. Let's count 5.
I just. Did you put points on there? Just try to draw them.
Yeah, should we put points on all of them? Like if we get to
I
general
mean, if
shape?
I'm telling you to do a sketch, sketches don't have to be real precise.
What's this schedule of graph?
So if I put in 1, we get 2. Okay, if I put in 2, 8 plus 4, I'm getting 12. If I put in 3, 27 and 9. So we can see from 1 to 3. Oh, missed my point. I missed it again. I don't know. My depth perception is off today.
I really will laugh if you missed it a third time.
Okay, so there's my graph. And what am I doing to that?
Oh, let's go over the x-axis.
Rotating that around, the x-axis.
Yeah, I did that wrong. I did it backwards. Oops. I got the shape right, I just filled in the wrong area, because I don't know how it
Oh,
works.
yeah, so I was way wrong.
She's the worst that Miss Carla loves to hear.
I thought it looked like an hourglass.
Hey, so I want you to know my graph might not be that symmetric.
That's okay. I'm really just wanting to make sure you have some idea what's going on here. Okay, so if I am looking at that graph, and we are finding the region, we rotate around the x, so we keep it in terms of x. Where are we going to integrate from? So it's pi times the radius squared. We don't have anything hollowed out of the center, so we don't have to do washer. My radius, if you think about wherever you might take your cross section, your radius is just your curve. So that's x cubed plus 6 squared. Alright, so I'm going to take out my pi. So to square that, you'd have to write it twice in FOIL. So you get x to the 6th.
It's a really nice.
That was some rough.
Just for my own sake of knowing how to FOIL, when you multiply common bases, you add the exponent. Okay.
First, outside, inside.
I always want to multiply the exponents, and it's never good for me.
I think it did take me like 3 tries to like foil that correctly.
Really?
Yeah. No, it's just because I didn't do it correct. I don't know.
Because it's not what you're used to foiling.
We don't usually.
You did that foiler.
I am that foiler. Thank you.
You do.
Yet you can foil plans, you meddling kid.
What?
Is that the guy from
Scooby-Doo.
Scooby-Doo back there?
Okay, so, ooh, this is not pretty.
Oh, it's really
What?
pretty.
It's very ugly.
That is special.
Hey, but we
And
do
we have the numbers, so we can, and so do you. I'm saying like,
Hey, do you ever
Right there.
got the right answer? That's all that matters.
yeah, that's all that matters.
And that came out to be,
This came at 63352 pi over 105.
sorry, might have made that one up.
Maybe.
Maybe, there's a chance.
And then we get that on the test.
Oh my
So
God.
average value is just an integral.
Oh, that's-
The only difference is you need to divide by the length of the interval.
Oh yes.
So it's 1 over the 4 minutes.
Stop her.
So we have to multiply by 1/3 because the interval is 3 long. Alright, now do your antiderivative. So if you add 1 to the power, that's 1/2. So you would put a 2 in front. 2/3 square root of 4 minus the square root of 1. 2 minus 1 is 1 times 2/3 is 2/3. So this one you have two options. Substitution actually will work here, but I think the easier option might just be to multiply it out. We can go either way.
Oh, I did
You would-
substitute.
We can do substitution.
I tried, I didn't get
Wait.
very far.
If you do substitution, your u needs
It's
needs to be
easier
this
go to the
inside.
fourth.
Probably not to the 4th, I guess. Whoops, I said 4 and wrote 4. So your u would be 1 plus the square root of x. Okay, think about what that means. That's the same thing as saying 1 plus x to the 1/2, right? So your du, derivative of 1 is 0, derivative of x to the 1/2 would be 1/2 x to the negative 1/2 dx. But if you think about what that means, we don't need the 1/2, so we can multiply by 2. X to the negative 1/2 is 1 over the square root of x.
Wowzer.
Oh my
So
gosh.
this is your dx. So if you change your limits, if you put a 1 in, 1 plus the square root of 1, so 1 plus 1 is 2. Put in a 4, square root of 4 is 2, plus 1 is 3. Then we have u to the 4th, and the 1 over radical x dx gets replaced with a 2d. So we have a 2 and a d.
That's beautiful.
What's beautiful are these fractions.
You don't have to